Welcome and thank you for joining us for SICRAT 2021, a series of virtual seminars on critical topics in the conservation of earthen architecture. My name is Brooks Jeffrey. I'm a professor of architecture at the University of Arizona, and I'll be serving as the session moderator for today's topic, repair and maintenance of earthen architecture. Before we get started, I want to recognize that the University of Arizona occupies the original homelands of indigenous peoples who have stewarded this land since time immemorial, and we honor their legacy. Let me first take this opportunity to acknowledge all of those who have made SICRAT 2021 possible. First, our partner organizations, Vanishing Treasures Program, the National Park Service, the University of Arizona Office for Research, Innovation, and Impact, the University of New Mexico's Historic Preservation and Regionalism Program in the School of Architecture and Planning, and Cornerstones Community Partnerships. I also want to thank my colleagues on the SICRAT 2021 Planning Committee, Lauren Meyer, Francisco Uviña Contreras, and Jake Barrow, who have been working incredibly hard under COVID conditions to create a virtual alternative to the TCRAT workshop we had intended to host this year, but wanted to keep the momentum going until next year when we'll be meeting in Santa Fe, New Mexico. I'd also like to thank all the panelists who have agreed to share their expertise, their experience, their successes, and their challenges in their work. As you'll see throughout the entire series of seminars, many represent National Park Service parks, but we also have active park practitioners, academics, and representatives of community and tribal organizations, all dedicated to advancing the conservation of our earthen heritage. Finally, I'd like to acknowledge the heroic efforts of Ashley Oliveros, an event coordinator from the University of Arizona's Office for Research, Innovation, and Impact, who is the wizard behind the curtain of the registration process, the Zoom logistics, and today is doing her magic to make this virtual event as seamless as possible. Thank you, Ashley. We couldn't do this without you. For those of you who are not familiar with the tradition of the SICRAT, the seminar format, or the TCRAT, the workshop format, this all began in 1994 as a cross-border program between the National Park Service and its Mexican counterpart, the National Institute of Anthropology and History, or INAH. This program convenes experts from the United States and Mexico to share current best practices and case studies, and working directly with the communities on both sides of the border, using hands-on workshops to teach conservation skills and help those communities preserve their earthen architectural heritage, and by extension, preserving pride in their community. In essence, the SICRAT or TCRAT program is a community of practice, and we encourage you to engage with the panelists in this series and with each other as part of this community. This year's virtual SICRAT is intended to be the foundation for next year's TCRAT workshop, which will be held in conjunction with TERRA 2022, the 13th World Congress on Earthen Architectural Heritage, taking place in Santa Fe, New Mexico in June. Links to TERRA 2022 can be found on the SICRAT website, which is in your chat, where you registered for this session. And this website also has links to the Missions Initiative website, where we've built up a library of resources, including previous TCRAT presentations and videos that still remain a great resource of instructional tools on earthen conservation. Now, some orientation as to how today's virtual session will be conducted and how you can participate. First, each of these 2-hour sessions will be divided into 2 parts. A set of brief presentations by our invited panelists that will take up the first hour or so. Then we'll take a 10-minute intermission and come back for the Q&A part of the session for the second hour. To save time, I'll be introducing each panelist's name and affiliation before their presentation and then turn it over to them. If you're interested in more information on the panelists, please visit the SICRAT website for complete bios and even a pretty picture of each of them. And we encourage you to ask questions during the presentations, but they must be submitted using the Q&A feature on Zoom at the bottom of your screen. You may want to wait until the intermission to post your questions, especially if you think the question will be covered by another panelist's presentation. I will be monitoring and compiling these questions, and if they were not already covered by the panelist presentations, we will use them as a framework for our Q&A discussions in the second hour. And just so that you know, the chat function in Zoom has been disabled for audience participants, but will be used by Ashley and the panelists to post links, additional resources, and other information. And finally, this and all the SICRAT 2021 sessions are being recorded and will be available on the Missions Initiative website and eventually the Terra 2022 website, with a goal of creating a foundation of content for future TCRATs, including next year's in New Mexico. Now, on to today's topic, repair and maintenance of earthen architecture. Our first panelist today is Jeremy Moss from Pecos National Historic Park. Jeremy, take it away.
Welcome everybody to SICRAT. I wanted to start out today to cover the basic principles in the conservation of earthen architecture, trying to provide a framework of guiding principles and things to consider when planning or thinking about treatment of earthen architecture. The idea is that this will provide a little bit of framework and background for some of the presentations you'll see in the rest of the session today. Some of the things we're going to consider today is what we need to think about when conserving earthen architecture, what influences our decision-making process, and how are treatments selected. There's a lot of factors to consider when planning treatment on earthen architecture. Many sites or parks within the National Park Service have selected different methods, and there's not one size that fits all. Many of these methods or treatments are selected based on a complex set of considerations. Here we have examples from Pecos, Fort Union, and Tumacacori, all showing different methods and techniques used to deal with the unique site histories, amount of original material left at these sites, and interpretive values. However, there's a large range of things that must be considered when thinking about how to choose treatments. Oftentimes, these factors relate to site history and significance. So again, we want to make sure that treatments that are planned or executed are in keeping with the history and significance of the site and still allow us to tell the story. We also have to consider National Historic Preservation Act and compliance with Section 106 and National Register character defining features. Often this requires SHPO consultation. Whenever planning a treatment, you really need to be in contact with the State Historic Preservation Office if you're considering treatments on eligible sites that are eligible for the National Register or are already listed. And consultation with SHPO can really be an effective way to develop treatments that are sensitive to the resource and consider character defining features. Integrity is an important concept to consider when planning for treatments. These include materials, workmanship, feel, and setting. Interpretive goals and parks or resources, fundamental resources and values, or a site's fundamental resources and values are important things to consider as well. Oftentimes, many of the treatment decisions that are made have to do with interpretive goals and the way the site is meant to be presented to the public or to visitors in order to tell a story that's fundamental to that site or that park or resource. We also have to consider concerns of ancestral or local communities or ancestral related communities. Some of the treatments we do are considering may be offensive or culturally insensitive to traditionally associated communities. There is also a great opportunity to work with those communities and educate about conservation of earthen architecture through much of the work that Cornerstones and the TCRATs, as Brooke mentioned, have attempted to do. It's really important work to help train people in preserving their own resources. Cultural landscapes is an additional consideration. Sometimes the treatments that we're considering may have an impact on the feel and setting of the site, and we need to consider how the cultural landscape is being interpreted in relation to a specific structure or site. Material compatibility is also a really important characteristic, important thing to consider. Sometimes treatments that are made with materials that are drastically different from the original materials that they may be up against or interact with can cause additional damage or have unforeseen consequences. Along those similar lines, reversibility is a basic concept in historic preservation that we always have to consider when planning treatments on earthen architecture. How easy can the treatment be reversed if it fails or it doesn't work as well, or if adjustments need to be made? Will there be damage to original material during that removal? So that relates also to invasiveness. How invasive are our treatments? We need to make sure that we have both reversibility and the treatments are not so invasive that we damage original material or we can't go back and correct any failures or issues that come up. So the durability of materials used in treatment is also a primary concern, especially in the Park Service or at other sites where we have budget constraints. And that's where preservation maintenance cycles come in, and developing an understanding of how long a certain treatment will last and when it will need to be repeated is crucial for planning and for seeking funding. So whenever planning these projects, these things are considered and should be monitored after the treatments are done as well. So budgets are often a primary concern or a concern that really drives decisions. We're always trying to balance these factors and hopefully come up with a treatment schedule or treatment materials that don't reduce the integrity of the structure or of the site, but also that we can execute and is sustainable over time. Visitation may impact the treatments we select. Sites that get heavy visitation may need different types of treatments than those that don't. So this is another factor to consider when choosing treatments. Oftentimes the less is better approach is the best, but when we're dealing with visitation, sometimes the impacts are so extreme that we may need to do a little bit more treatment work than we might want to. Current scientific research and knowledge is always something we need to consider when planning treatments, and past treatments or what people have done before us often dictate the direction we'll take, and hopefully we're learning from past treatments, past mistakes. Someone will always come after us and think they can do it better. As long as we make informed decisions and consider all the factors on this slide and document how we considered them and how we selected our treatments, we're on good footing to move forward, especially if we're doing it in consultation with the State Historic Preservation Office and other experts. In order to develop a range of treatment options and to implement them, we must have a good understanding of causes of deterioration. This is just a short list. Each site might have unique factors, but weather and climate change are often primary factors. Having an understanding of the seasonality of weather, when does precipitation come during the year, will help you plan treatments and develop treatment strategies. Climate change, increasingly the increased rainfall and intensity of storm events is impacting some of our treatments and is a consideration. Local soils and geologic contexts need to understand how erosion may affect a site and drainage patterns. Local hydrology, how close is bedrock, how does water drain from the site or approach the site are important considerations. Snow and rain patterns and aspects of walls. It's pretty common to look at the north side or north walls, and east walls are often get more impact from moisture. And moisture is really the #1 cause of deterioration of earthen architecture. So much of what we'll be talking about today and in the case studies that we be presented have to do with dealing with the effects of improper drainage and impacts from moisture intrusion and instability that it may cause. Preservation documentation needs to be considered whenever planning treatments. At a minimum level, before, during, and after photos need to be taken to document the treatments. Documentation is really important if we're going to learn from our past failures and learn the successes of our treatments and show them to others. Lighting needs to be considered during photos. So you often need to go out when the light's even and it's a little cloudy is usually the best time. North-facing walls will be more difficult to photograph. Photo logs, notes, north arrows, vertical and horizontal scales, and measured drawings are crucial. Next, I'm going to show you a method, just one method of how Pecos NHP protects original 17th and 18th century adobe walls. As I said, many parks and sites are using different methods, although there are the basic principles we went over, they're using different methods, and some of that is based on the history of treatments on the site. And at Pecos, the use of brick veneers to protect original walls and protect and provide the form and outline of deteriorated Spanish colonial walls of the church and convento started in 1915. Since then, we've been honing that technique. And now I'm going to show you a series of photos, including an animation at the end that shows how we do this method or technique. So here we're seeing the way we do it at Pecos is we encapsulate the original material, the original adobe wall remnants in a new brick veneer. We make the bricks on site. So it is a form of encapsulation or shelter coating, but in this case, we're using actual adobe bricks. We don't plaster over the bricks typically, and that's again related to the interpretive values that seeing adobe brick gives you. This was a decision that goes back quite a ways. And we really want the public to come away with an understanding of the construction of the site. Therefore, even though we know we might get a little more protection out of building veneers with plaster and plastering all of the veneer surfaces, this was an interpretive decision that was made a long time ago. We continue to execute, but we find that we get about 7 years out of our veneers and sometimes more. So then we have to replace these veneers, and replacing the veneers requires the removal of the old veneer and the building of a new veneer. So here we can see half of an old veneer removed, and on the left side, original adobe wall is exposed that dates to the 1600s. We can also see the effect of us getting a little behind on our preservation treatments, where you can see a rodent had tunneled into the original. Unfortunately, this was an example of our monitoring not catching this problem soon enough. This was a small rodent hole, and unfortunately, we didn't get to it quick enough, and there was damage to original. So after we remove the old veneer, we document the original, and then we put on a unamended, so completely natural plaster coat in order to provide an interface between the new veneer we will build against the original and also just to protect it during the work. We are adding a small amount of Roplex E330 to our stabilization bricks. And as a basic philosophy, we never want our amended material to make contact with original material. So this separation coat also provides that protection. The amended material can trap moisture. So while we're using a small amount of amendments, we're trying to do it in a way that hopefully doesn't impact the original, which becomes really the core of the wall. And then we are maintaining the veneer after that point. So then we build the new veneer from the base up with the bricks we make on site. Here's Mason Jerry Garza laying the bricks against the original. We're doing one side at a time this time. So we're just doing one side of the veneer, and the original is protected behind the shelter coat of the unamended shelter coat. And once we build the veneer all the way up, we also work on the cap. And here's an animation to show before and after. Magic. So I hope you got an idea today of the basic principles and factors to consider when planning any treatments or preservation work on earthen architecture. I hope we've made the selection of those factors just a little bit clearer. And I hope that you'll be able to come visit us at Pecos National Historical Park someday. It's a pleasure being with you today. Thank you.
Great, thank you, Jeremy. Next up is Francisco Uviña Contreras from the University of New Mexico. Francisco.
My presentation, it's basically very similar, and I'm going to follow on some of the things that Jeremy touched on, and what other people will follow as well when it comes to, presentation, the presentation in the main topic, when it comes to the SICRAT, this seminar. So maintenance can become a very difficult task when you are dealing with historic archaeological sites at the national parks, state sites, local government buildings, private homes, and businesses. It is essential, like Jeremy mentioned, we need to make an effort in understanding the cyclical weather conditions and its changes through time. This includes ways of draining water away from the site. You will see some examples during the presentation to follow. It is important to note the variety of protections to your building walls and other elements, such as what this sketch shows: a good hat, raincoat, and a good high boots. This does not mean This does not mean we will make everything impervious, but instead, whatever we select as materials will be compatible and sacrificial before the substrate material is affected. Maintenance is part of the nature of these earthen buildings. You will continue to hear that today and in the following weeks. The historic images to the left depict indigenous women in mud plastering their exterior walls. While the image to the right, are actually indigenous women, in Laguna Pueblo, redoing the San Jose de la Laguna Mission earth floor. I was so lucky to have been there that day taking these pictures. Not only were they refinishing the floor as part of the church maintenance, but keeping a tradition alive. Only women were allowed to do the work, while men were outside preparing the mix. Another intangible aspect of the annual care of cyclical maintenance of these buildings takes place in the Hispano village communities. These series of photos show a living tradition that we are in danger of losing. A key component to these buildings are the mayordomos. Sorry. Um, where was I? The series of photos show a living tradition that we are in danger of losing. A key component to these buildings are the mayordomos or caretakers in these communities, ordering or organizing the communities to replaster and maintain their adobe churches to prepare for the annual función or feast day. For example, La Iglesia de San Francisco de Asís, to the left, this is in Rancho de Taos, San Jose de Gracia in the center, in Las Trampas, and the most modest of them all, the church in Monte Aplanado, near the Mora Valley. What that still continues to the task of maintaining their mud plastering traditions. How we can promote the cyclical maintenance in these many structures that we have in the state and region. So the next few slides will show you examples of bad interventions or decision making. These methods of intervention for good or for bad don't just happen in the States, but all over the world. The first example shows Casa Grande in Arizona, as well as Arroyo Seco Church near Taos, and two common mistakes that often occur. The cementitious or impervious coatings and the concrete aprons applied to walls with stone foundations, or in some cases with no foundations at all. Not only is it necessary to carefully remove these harmful surfaces, but how to repair or consolidate the material after removal. The next slide shows a careful consolidation in an archaeological site in the northern region in El Peru. You can see the art conservators repairing or injecting mixtures of clay with a bit of lime, in some cases to reintegrate earth reliefs or pieces of decorated or polychromatic surfaces. This slide shows how our colleagues in Mexico repoint mortar joints. There are ways of making distinctions when it comes to actual repairs in several regions throughout Mexico. Our colleagues and friends from INA, like Brooks mentioned earlier, the Instituto Nacional de Antropología y Historia, use a system of rajueleo to distinguish where the walls have been consolidated or repaired. The rajueleo system is that where small pieces of volcanic or lava rock, broken ceramics, lighter stones, and or other materials available to use for chinking the mortar joints in stone masonry, as well as adobe walls. It might not be easy to do in an earth mortar masonry structure in our region, but it could be tried or could be modified to fit our needs in this region. What about our shoring needs? When it comes to these fragile and failing walls, it is of vast importance to shore up walls or structures if they are close to collapse, or if they feel they need it in case you have visitors getting too close to them. The shoring system should be one in which architecturally and aesthetically pleasing speaking fits into the context of the site, landscape, as well as the materiality of the structure or building. Shoring can be temporary, but in turn can become permanent, as seen in the San Lorenzo picture to the right. This is the San Lorenzo, Santuario San Lorenzo in the historic town of Bernalillo. The other slide shows an oratorio of Jesus Nazareno in the community of La Jara. the Oratorio Jesús Nazareno in the community of La Jara, where a lack of good drainage caused these walls to fail. The walls were constructed in a very unique encofrado manner, or boxed-in walls, which they call paredes de cajón. Mud and rocks are laid in wood forms similar to rammed earth. Then the formwork is removed. The only way to repair this building was to extend a temporary beam from the interior to the exterior in order to allow us to work around the structure and near the wall. The next 7 slides will depict the effects of adding concrete against a wall and the careful removal and repair of the base of the walls. We start with a quick diagram showing what to expect in a wall when carefully removing a concrete apron. In some cases, like the slide shows, vegetation growing between the concrete apron and the wall can also be an issue. This photo was taken a few days ago in a small adobe structure in the village of Los Lunas. The following slide shows a temporary shoring system composed of plywood through bolted and supported with the diagonal wood members to prevent kickback. This photo was taken at the historic Gutierrez Hubble House in Albuquerque. It is a long story, but we had to work quite fast since someone had kicked in the lower part of the wall. The good thing with this wall is that we had previously shored the wall, so it didn't collapse on us. These 2 images of the church Arroyo Hondo, or the Arroyo Hondo Church, shows the insertion of adobes along the base after a very large concrete apron with rebar had been carefully removed. While working with Cornerstones Community Partnerships, we were recommended a product called Bristar back in the day. But now you can find it with the name of bituminite. You create holes in the concrete, you then pour this miracle material, and what it does, it slowly breaks and cracks the concrete into smaller pieces. Please do not use pneumatic tools against these fragile walls. It is key to make a good connection with unamended adobes in order to have a good adhesion to the wall. Once again, you see a slide of Arroyo Hondo to the right and a slide at the church in the town of Bernalillo, which we discussed earlier in the shoring part. I will not get into how to do this, but there are times that if a certain percentage of wall is deteriorated, you then take certain actions. In some cases, you might need to have new adobes keyed into the original wall, but in some cases, the use of mud plastering layers with light stones or other light material could work just as well. This next slide, which took place at the Gutierrez Hubble House in Albuquerque, shows this young man laying adobes and allowing them to dry before hard packing the top of the new adobes with the original wall with the use of dry mud. This is done to prevent shrinkage and separation of new adobes to the original wall, therefore making this a more monolithic wall. The next 2 slides show through sketches what a wall should look like when repairing the base with new unamended adobes. Remember, it is important to remove the cementitious, not to remove the cementitious plaster, especially since in most cases, these plasters can become a structural diaphragm, and its removal should only take place at intervals a few feet apart. 1, to allow the walls to dry, and like I mentioned before, it retains the rest of the adobe wall in place. Notice the keys, which are important when working on specific areas of the wall. These eventually will serve to connect all the repairs and make it into a continuous adobe coursing at the base of the wall. The last slide shows how it should look after the repairs have taken place along the walls. Observe how well crafted Pat Taylor and his crew repaired this wall at the Socorro Mission in the city of Socorro near El Paso, Texas. And a quick sectional diagram showing you how to key in the adobes while working on the basal repairs. Many of these adobe repairs are tedious, such as this example at the Gutierrez Hubble House site where we worked with a local group of young men. The slide is depicting the lack of good connection at the corner of this building or the Casa Hubble. It was not structurally failing, so we decided to stitch the walls with adobe in situ, or adobes that were actually made in situ. This case, we happen to carefully remove the half pieces adobes in order to insert a full one. We jumped from the lower area of the wall to the top and so on until we were able to complete all repairs. Notice the similar shoring that you saw in the previous slides in the same house. Let's quickly touch on mud plastering. There are different ways of applying mud plasters onto the adobe or stone masonry walls when plastering a wall or site. I prefer to throw the first coat onto the masonry or earth walls. It is not commonly used in the States, but it's a common practice with our neighbors to the south. The albañiles or masons have been doing this for centuries, and it is common to apply the coats of plaster in this fashion, especially since they typically don't use wire lath for their contemporary construction practices. It is time and practice, but it can easily be mastered, thus can move along quite fast when you get used to it. The other practice is with the use of the hand, as you can see in this slide. In some cases, it can get a bit longer, or take a bit longer, but works just as well, especially when you push the mud into place. The sketch to the right shows how the path of water is broken with the use of straw and large aggregate. It is sometimes difficult to find good soils used in some of these sites, especially when the parks do not allow. Wrong paragraph. Let's quickly touch on mud plastering. There are different ways of applying mud plasters onto the masonry walls. Wait, I've already gone through that. It is sometimes difficult to find a similar soil used on some of these sites, especially when the parks do not allow the collection of on-site earth materials to be gathered to make adobes or repairs. It becomes a difficult task, especially if you don't have the local members of the community that might still know the knowledge for seeking good soils, in good soil deposits within that area. I suggest experimenting with the soil and even creating a variety of test panels to obtain appropriate mix, especially if you are thinking of mud plastering your site or monument. You could even explore or utilize a very small percentage of lime in your mix. In this slide, you can see the two methods of application, but the diagram or drawing to the left is an experiment you can try at home. Place one size marble into a container and stick your hand through to touch the bottom of the container. Now take the same container and add a variety of different size marbles, beans, beads, and other angular elements. You will see that the hand does not go through. This demonstrates the ability of different size particles connecting and connecting and making its way like a puzzle and making a really tight fit. This goes to show you how a good distribution in the granulometry, your sand or gravels, can improve your mix. And of course, the final coat can be applied with a trowel over a rough or scratch first coats of plaster. Very quickly with the following two slides. One, never utilize a hard mortar to lay adobes or stone masonry. The softer the material, such as the adobe or stone, will deteriorate faster and cause that we actually will see the honeycomb effect, like we're showing you in this slide. Even this wall that was recently built, you can imagine what it would do to an older adobe wall, which we constantly deal with in our line of work. Capping, very necessary to do it right. Most of you know this already. Do not apply hard or more rigid materials to the top of the walls. It is of great importance to keep the soil or the material composition as compatible, like Jeremy mentioned earlier, as possible. This might take a bit of time to come up with different mixes with a good amount of straw and large angular gravel, and if possible, a very small percentage of lime into your mix. Remember, straw is a material brought in by the early colonizers. Adobe is a masonry unit utilized by early colonizers. However, the use of adobe already existed in the New World and in this region. The use of adobe was just taking off and had not been extensively used, at least in this region. Most of the early adobes found in this region were hand molded with lots of grass. Not because, remember, no straw. That was a European product. One thing to remember, especially to our archaeologists and friends, not because it is earth, it is considered adobe. Once again, it It's not the material, but instead it is a masonry unit that can come in different sizes and forms. Going back to the inappropriate methods for drainage and the incompatibility of materials, such as cementitious plasters. This example of La Iglesia de San Jose in Rociada Arriba in northern New Mexico shows us that after many years of a lack of good drainage and allowing the exterior soil to accumulate beyond the original grade can cause issues to the building. Plus, let us not forget the cementitious plasters applied to the exterior walls. Notice the person digging, he is now standing at the original grade of the church, along the exterior wall. The next couple of slides will show you a quick diagram of how the wall gets intervened with man-made and impervious materials and the effects of it through time. So this is like when moisture is rising, keeps rising, and we keep putting impervious surfaces onto it on a concrete slab. And then, a concrete apron that eventually will retain the moisture and weaken the base of the wall. So this basically shows, and this one is going to be really quick, but I really wanted to show you the drawings, when it comes to this particular building of San Esteban del Rey in the Acoma Pueblo, so the San Esteban del Rey mission. So we can see Pat Taylor and Antonio Guerrero, our colleague from INA. He's an architect and specialist in earthen restoration. So these are the evolution of the drawings that we proposed for the clerestory window. And of course, once the engineer gets a hold of it, we actually start to improve it and eventually, make it into an AutoCAD drawing. Jeremy did mention this, documentation is very important when it comes to these buildings. So I'll stop it there, Brooks. Thank you, everybody. And I hope you stick around for the next presentation. Thank you.
Thank you, Francisco, very much. Our next speaker is James Mason from National Park Service's Vanishing Treasures Program. James?
Okay, thank you, everyone. My name is James Mason. I'm an engineer. I cover structural, geotechnical, preservation, and seismic engineering. And I wanted to make some comments about engineering considerations for adobe masonry structures. What I want to cover here today in terms of structural components of adobe, we'll be looking at the compressive strength, shear, tensile strength of adobe brick and mortar. I'll talk about basic structural frames. An important area is the attachment of adobe buildings to a foundation system. And then I'll have a special seismic performance load case, and we'll talk about building load paths. I'll be using two case studies. The first one is the hospital building at Fort Union. And then the second case is a seismic analysis of the Martinez Adobe home in Northern California. So the Fort Union site was built during the Civil War, and it was the distribution point for supplies to the Western United States. The fort was developed in 3 phases. The first phase were earthen structures. Then they moved over here to the second fort, and this fort was abandoned because there was this large mesa hillside here where the Confederate armies could attack the Union armies that were here at the second fort. So then they moved it out here into the middle of this plain. And also it was immediately adjacent to the old Santa Fe Trail. The construction methods in certain areas, they would use adobe, and then it would not be covered for weather protection. And then it would come down immediately to a stone foundation that was created by having outerwise of stone and then a rubble infill in between, and the adobe wall built on top of that. The building that I'm going to talk about today is the hospital building. And this building has adobe walls with flat timber planks that covered the adobe for weather protection. It was a fairly large structure, multiple structures that were linked together there on site. I was called in because there was concern about a particular wall within the building. So the picture that we just saw was taken over here in this area, looking north. So this is the south end of the building. And I was called in to look at this wall, which was within a hallway. The concern was this wall collapsing and falling into this series of walls, taking out a large area of original structure. Here are two pictures that show what work that had been done back in the late 50s and early 1960s. This is how they found the wall. This is the wall I'm talking about. It's a 3-wide wall, and you'll notice that there are no bond courses in this wall at all. They're all running bond throughout the full height. The work that was done was they went back and essentially filled in the cracks and gaps of the wall. At this point in time, the lean to the wall was minimal and not of great concern. I was called in 2017 to look at that wall. This is the same view from the prior slide, and you can start to see the amount of rotation of the wall. And what's really hard to see here is that there is a wire that comes down here. That's a 3/8 inch wire that is embedded into a deadman, and then it goes through the wall, and there was a frame that was embedded in the adobe. By calculation, this wire should have broken. So it's pretty incredible it was still in place. This is looking at the same wall. So this end is actually this end down here in the southern view. You can see the wall rotating and this crack, this fissure that's going through the wall. So I went back and started to lay this out and do some calculations on the structure, on the wall, and looked at what were methods of actually doing something. You take it down fully and reconstruct it and such. And I came up with this concept that I show here in this right-hand slide of being able to actually push the wall back up into place by using steel shoring as the reaction to push the wall up against. And then the load path for that push would actually go back through the existing adjacent wall and into another load frame on the backside, and then ultimately take all that pushing load down here into those ground anchors. You can see that this wall was rotated about 8 degrees. That's 18 inches in 12 feet of wall height. It's a fairly thick wall. By calculation, it was going to take 4 20-ton jacks to apply the initial force to push that wall back up straight. Here, we're looking at the wall right here. This is the frame that we would push the wall against, and this was aligned to be plumb vertical, so that would tell me when the wall would be up straight. You can also see the condition of the foundations. As I was mentioning, there's exterior wythe, stone wythe, and then rubble infill. This is a quick slide showing how that load path comes down to ground and the capacity of the steel rods. Just a heads up, the Red Cross has references for the capacity of rods and for lateral loading. Here are some of our colleagues out building that frame. And just a point of mention about safety, on the morning that we were going over to work on this wall, coincidentally, this whole section by itself collapsed. I'd walked through over here. I was already giving great room to the wall, but I looked up and I said to my colleagues, we've got to stay out of here. And I walked through the wall over here, and the wall, that section collapsed just as I was walking past it. Here we are moving this trenching shoring. This is used in common urban environment, and it's a rigid system. We brought in a crane to lift it in. And then we can see on the left side that we put the frame in. You can see how out of plumb this wall is. Again, this is a vertical line, so you get an idea of the of how out of plumb. And then we dropped in these panels. So these panels were strengthened to take these point loads. So these are 4 20-ton jacks that we ran off to a single manifold, and we could manipulate each of those jacks individually. Once we pushed up and got the load onto the wall, then we came in, had to clean out all the cracks of all the prior mortar that was placed in those cracks. The view on this on the right here shows that there was load coming in. This is on the back side of that wall, and you can see how some of the foam has been collapsed. To mention, that's a structural foam that you can dial in the compressive strength. And here we are in process of pushing the wall back in. Once everything was cleaned out, we had to dig down and clean out this joint and push it back into place. And here we are in process. The wall, this wall, it finally came up. It was touching until this came to here, touching. This is when the wall was finally in place. And remember, this wire used to be under tension, and you can see how much slack came out of that. And then here we are with the wall in place. This slide shows that this is the reaction side, and it shows that there was movement, which means that this reaction frame was actually taking load. At the end of the project, at the end of the straightening, then we went over and they built an end column pillar and keyed that into the end of the wall. And because this wall was exposed to high winds out on that huge plain, I designed in a T brace that would go on top of the frame. It's a fiberglass T frame. And then we used drill and bond to insert anchors down into the wall at these special positions to take the lateral wind loads that come onto the wall. Another view of that. And then because this was a test section, we tested various mortar caps. We did natural hydraulic lime, a amended mortar, a pure earthen mortar, and then we tried also some cementitious grout. And here's the wall in place. The next subject that I want to cover and looking at all this is the condition assessment of the Martinez adobe. Quickly, the Martinez adobe was awarded to Senor Martinez, who was part of the Mexican Navy back in the early 1800s when they occupied California. He was granted over 17,000 acres of land. All in all, a long story short, it ultimately went to this gentleman over here, who is Dr. Strenzel, a German who came to the United States. And then John Muir married Dr. Strenzel's daughter, and then Muir moved to the property. And so it's known as a John Muir house. So here we are, here's the John Muir house. That was Strenzel's original house. That's a Victorian era structure. And here's the Martinez adobe. Here's a view of the home. This was taken back in the early 60s. It's at the base of the hill. The structure went through several changes over time. And you can see some of this in terms of a lean-to shed and a cistern. So here was the structure in 2017. What I want to point out is that this building here are the adobe walls. They also have the plank clapboards over the exterior, and it's a rubble foundation. So this system is really just sitting on a pile of rocks. And I went in and was asked to originally look at some crack patterns in the system and look at some of the settlement. But once I started really looking into this, I realized that some work that was done in the early 1990s for seismic retrofit wasn't adequate. So that's what I want to talk about. The cracks in the wall, I read cracks in the wall, they show me movement. And this wall in particular had two kinds of movement that were going on in the wall. This shows the settlement of the chimney. Here's the cracks in the wall. And then what's happening here is that we have both shear loading and lateral loading. And it took a little bit of thinking about why we have these two different actions at this one place. And I'll show you the details of that in a minute. I mentioned
James, we just got 2 more minutes.
Yep, I'm there. In 1993, they went in and started working on this structure. They put in some what are called needle beams. I highly suggest that you understand the compressive strength of your adobe before you start jacking it. They cause problems with those needle beams, and they thought that they were encasing the foundation. That did not happen. So here's a superposition of the work. You can also look at trees as sucking moisture away from your structure, causing settlement. Here's the actual settlement that was measured back in 1993. You can go through and calculate the chimney was leaning, and I could put numbers to this to justify an understanding the leaning of the wall. I also went through and did geotechnical analysis showing that there was actually a slip failure occurring underneath that end of the wall, and that's what was forcing that lateral movement. I also went through and looked at the outer movement and came up with that there were 2 hand-dug wells. They were mentioned in an HSR, Historic Structures report. I modeled the well and showed that there was movement equivalent to what I was measuring in the field. Then comes the earthquake part of this story. The earthquake part of this structure survived in 1906, but if it gets hit by the fault earthquake on the Hayward Fault, it lacks all the detail of this structure to be able to sustain that load, and it would literally fall over. These are details that were drawn back in 1993, but were not implemented. So here we see photos of that sill plate. The anchor is up here. And the last thing I want to bring up is when you look at a structure and calculate how it's going to perform in an earthquake, you have to find the point of rotation of the building. In this case, the point of rotation was not symmetric with the walls. So that'll increase the shear demand to the building in addition to the shear caused by the earthquake. These calculations show that. Lastly, what I did was I looked at 2 different methods of trying to keep the structure together, and I came up that what would work is what's called base isolation system, where literally we're going to jack the building up, build a new foundation underneath, put in these plates. It's a stainless steel and Teflon plate between the original structure. We'd stitch together the walls and put in a wall system, and then the first floor system would be a free floating system within the wall section itself. And you could do the same with the chimney. Here I'm showing stitching patterns that you would need to hold the wall together once it was all put up on the base isolation. Okay, thank you.
Thank you, James. I think we could do a whole session on earthquake and seismic. It's a huge topic.
Yeah.
All right, our last speaker is Jake Barrow from Cornerstones Community Partnerships. Jake?
And thank you very much, Brooks, and my predecessors here, and for everyone being in attendance. I'll try to be very quick to make up some time. I'm from Cornerstones Community Partnerships, and our mission is to work in partnership with communities to restore historic structures, preserve cultural landscapes, encourage traditional building practices, and conserve natural resources. Our basic approach is to follow the lead of the community. We're out in the community looking and responding to their requests to repair and maintain important earthen and traditional built structures in their communities. And our entire focus is on the needs of the community. And it's very important that we get those community members to be involved in those projects. Another focus that we're involved in heavily is the use of volunteers. And we rely on volunteers either from the community or from outside the community to come in and participate with the work. In this particular case, it's a youth who is mining a clay bank, a very, very rich clay bank, and helping us to get some materials and for work that we're going to do. Materials like those require very, very extra processing. Those pieces of a solid clay bank like that come down as rocks, and they have to be broken up into a sandy or a much finer aggregate to be a much finer size to be mixed into the adobe products. In our work, one of our first goals is to make adobes usually on site. And we find that in all of our projects, we need adobes. And so that's one of our first procedures is to make a good adobe that can be used in the repair of the buildings coming up. This is a 30-day approximately process. And so we need to plan this ahead. It's not possible to show up at the job site and be ready to work without having some adobes on hand. So we do this ahead. And each season, we typically are making adobes at the beginning of the season and stockpiling them for our work. One thing that we have found is that adobe making is very popular for volunteers, and we can usually attract volunteers both locally and from other places to join in the adobe making process. Francisco covered this very well. Stitching and building in adobe, we're using the same material for the mortar as we use in the bricks. This is all unremitted work that we do. And going up in courses, you have to be careful that those courses, four or five courses at the maximum, are fully dried, and so that you prevent settling before you go up with a new course. One of the focus points for our work with earthen materials is to fully hydrate the clay. And we have some barrels here where we're working with that clay that you saw a little earlier. And we find that this is a step that sometimes shortcut a little bit. And we like to get our clay in our aggregates 100% hydrated so that we get a full cementing process, both in adobe and in plastering. We use unamended earthen materials for earthen plaster on all of our projects. And what we have found is that if we're very careful with materials and very careful with application, the vertical surfaces can be very durable. And in some cases, we have vertical surfaces that are over 10 years old in the weather, and they're doing quite well. With buildings that have parapets or untreated caps, like the examples that we saw in Jeremy's and both in Francisco's examples and also at Fort Union, the cap will weather much more aggressively. And so in our case, we like to have a maintenance process going on to maintain those caps on such buildings. In 2012, Cornerstones joined the Desert Southwest Cooperative Ecosystem Studies Unit for the purpose of participating on public lands with the National Park Service and Bureau of Land Management to conduct workshops in the preservation of traditional building technologies. And for the Desert Southwest Cooperative, for these CESUs that are around the United States, all of which are set up more or less the same. So it's a very, very important and interesting process of value to the federal government, all federal government agencies. And it's a place where we all can meet together in a sort of figurative roundtable, nonprofits and government agencies to sort out problems and to find solutions, to put on trainings and to do pilot projects to solve these problems. Now with this, I'd like to move right into a video that's a case study that we just finished.
My name is Jason Thoyer. I'm the Cultural Resources Program Manager here at Joshua National Park. Cornerstone's involvement in a project like this is really important for Joshua National Park. You know, we have hundreds of historic structures that we have to protect and preserve of all kinds of different materials. We have wooden structures, we have masonry structures, and we have adobe structures like Ryan Ranch. And it's impossible for the park to have all that expertise in-house to deal with managing all these different types of historic structures. So our partnerships with Cornerstones provides a really valuable opportunity for the park to be able to bring in subject matter experts who understand adobe preservation, adobe stabilization, and the care and maintenance of adobe structures, right, very specifically. This partnership allows us to bring in those experts to partner with park staff and provide training to park staff and how to do this work, how to care for them. Also provide training and educational opportunities for the public to allow for volunteers to come in and also take part in hands-on preservation work, right, in maintaining, stabilizing, and preserving these really important and unique historic structures. We have a structure like Ryan Ranch where the nature of the work itself is cyclic and requires multiple years to complete that work, to do a preliminary test, to see how that test works, right, to assess the efficacy of our treatments, right, to apply a full treatment, and then to apply a retreatment. Right? Having a partner like Cornerstones who has the ability to stretch a project out over the appropriate lifespan for that project, right, becomes an invaluable resource for the agency.
Hi, my name is Isaac Logston. I work with Cornerstones Community Partnerships. We're here at Ryan Ranch at Joshua Tree National Park. Also on this project is Angela Francis, who's the lead plasterer. We began at this site by removing the failing lime plaster that's been here for about a decade. Big sections have been delaminating and falling off throughout the site. A lot of this is just sort of carefully removing the lime plaster that was put on as a sacrificial coat and general site cleanup. In addition to removing the sacrificial lime plaster, we're also trying to stabilize the edges of some of the original plasters. These were interior lime plasters that we suspect were done in the 1890s when the structure was built. In order to save these sections of interior plaster, we took away some of it until we could find stable edges, and then we stabilized them further using a natural hydraulic lime, or NHL 3.5. We brushed down the edges to clear it from debris and remixed the NHL with finely sifted sand. This stabilizes the edges, and it also creates a place for us to meet those interior sections with the earthen plaster that we're applying. A lot of this project is also just hauling materials to and from the site. So taking that failing lime plaster back down to the parking lot, which is a little over a quarter mile, and moving materials that we've been mixing up to the site. We did that by using a motorized wheelbarrow. The earthen plaster is just clay, sand, and straw and water. We were mixing down in the parking lot using a concrete mixer, and because it's pretty rich clay, we added the clay first and let it hydrate in the mixer, and then added the sand and straw. The clay came from near Lake Elsinore from a historic clay mine. We had to go further for the material because we couldn't mine in the park, and there aren't very many natural sources of clay around Joshua Tree. Once we located the right materials, we made several test panels, some just on plywood and others on the structure itself, using different ratios of clay and sand. From these samples, we decided on a 2 to 5 mix. That's 2 clay to 5 sand. Mixing and finding the right ratios was an important training moment for the park staff. They were able to see how different mixes reacted, how clay-rich mixes cracked, and the sandier mixes didn't stick as well.
Hi, my name is Tia Abe. I live in Oakland, California, and I'm currently at Ryan Ranch in Joshua Tree, California. Today we were learning just about the general earthen plaster tools and how to get set up. Working in this particular climate, which is very dry and quite windy, to kind of how to take care of the site so we can be working efficiently and strategically and working together well. And then we get into the plastering part, which is always the best part. And we learned how to hurl the clay, sand, and straw mix at the walls.
Once we had moved all of our materials up to the site, we were able to begin earthen plastering. We did this by wetting down the walls and hurling the material onto the wall. So this is done by throwing either with your hands or with tools. We also used our hands to push the materials into the wall and wooden floats to level out the different surfaces. After removing all of the lime plaster and thoroughly cleaning the walls, we started off with making minor adobe repairs. This was mostly so that the water sheds away from the wall rather than getting caught on ledges and further damaging the interior of the walls. During this first workshop, we worked closely with exhibit specialist Matt Sanford. He was able to learn how to mix, what to look for in the different ratios, and how to apply the earthen plaster to the walls. The earthen plaster that we put on is really a sacrificial coat, meaning that it's there to protect the adobes beneath it, and we're expecting it to erode over time. We're going to be returning to the park to help maintain the earthen plaster and taking care, especially to monitor the parapets or the tops of the walls, because those take the most damage from the rain and snow. The earthen plaster was chosen for several reasons. One, it's easy for volunteers and untrained park staff to work with, but also in the future for graffiti remediation and patching, it's a lot easier than lime, which is alkaline and takes a little more skill. Over the next few years, Cornerstones is going to work with the park to monitor and assess the walls. This will be done by site visits every 3 months or after any large rains, and just doing simple site inspections. The plan is for Cornerstones to return annually or when needed to replaster the walls. And when we do that, we're hoping to engage more and more local volunteers and build the volunteers into the project so that they have an investment and there's some accountability to look after this structure. Cornerstones is also interested in setting up the park for when our agreement ends so that they have the training and the right tools and the right materials to continue this preservation effort even after our partnership.
Just as a final comment, we have local assistants with us there at the project. Nicholas Holmes, Nathan McConnell, and Kyle Hansen, who live in Joshua Tree, are able to, they're 30 minutes away, and so that's a very great local support. We had 11 volunteers working on this project, and so we really feel encouraged about the concept of having volunteers being available locally to continue this process out of kind of like a friends group arrangement. And so that's the goal of what we're headed for here at Joshua Tree with Ryan Ranch. Thank you very much.
And thank you, Jake. Typically, what we would do now is to take a 10-minute break. I think in order to save a little bit of time, let's take a 5-minute break and then come back to begin the Q&A discussion portion of the session. I've said that you would like to answer the first one there by David Willett. And you need to take yourself off mute.
There I am. Okay, David, thank you very much. There were two issues about dust masks at that work site at Ryan Ranch. One is that the materials that the building was constructed of are mine tailings that contained trace quantities of mercury and also some trace quantities of lead. We had those tested, and they were very, very, very small. But we decided to use respirators for the demolition phase. And you didn't see that really in action very much. But we ahead of time, we used those hazmat respirators to get all that material down out of there and brushing down the walls in preparation for the plaster. Once that was all done, then the simple dust masks were used really just for dust in the air, and that was all that was. But it's an important question, and I'm glad you answered it.
Great, thank you, Jake. And Francisco, could you repeat the material that was used to eliminate the cement that you had presented?
Oh, back in the day, I guess it was the brand name was called Bristar, but then we found basically the same material, which is the company, I think it's, and I don't know if it's a product of the company, but it's bitonamite. And I can probably, you can Google it and you can actually easily find it. It's like the treatment that we use for termites, Borokill, which is more of the brand name than the actual, chemical composition of it.
Yeah, Jake, did you want to add something to that?
Yeah, I could add, we've used this extensively. These materials are basically expansive clays that really is powerful, and you add water, and if you're sequencing that right, like Francisco said, that expands and cracks that. Be very careful not to have it retained on both sides, because it can explode, so it can blow that concrete out. You have to be a little bit careful with that. But
the other thing to follow on what Jake said, it's also, I believe the composition of it, and I think Idea Orea, one of my colleagues actually, asked this, is that I think it's a composition of lime, which is like quick lime, which will expand, so you're basically mixing it with water and then it slowly expands. People in like stonemasonry that are breaking like large marble stones, and granite stones, use it all the time, because like Jake was saying, it will slowly, will basically crack and break, as long as you're not using large pneumatic tools. It's not that cheap, but, I mean, it will save you a lot of headaches in the long run.
Great, thank you. The next question from Robert Huber is, can you describe the methodology of treatment for avoiding plaster on painted mural on the wall in Tumacacori? Is there anyone who wants to take a stab at that?
I'll take a stab at that.
And Alex Lim looks like he's contributed too. So go ahead, Jake.
I think it's better if Alex responds. I was just going to talk a little bit about, he knows specifically what's happening with that, so get him on.
Great. I don't know if we can get him on, but it looks like he's answered to that question.
Oh.
The next question, there's Alex.
Hello, can
Alex?
You hear me?
Yes, yeah. Perfectly.
Well, briefly, it depends really on whether the eroding original stucco or plaster is exposed to the weathering. We have painted murals on plaster, not the other way around. Painted mural on plaster. On the outside, that's the facade, and on the inside the church, and they're treated quite differently for many reasons. And I see a related question about consolidation. So in the case of the interior mural, that's protected by the roofing and without the threat of weathering, we do consolidate the substrate plaster that has painted finishes on, because we know we can get some kind of warranty, so to speak, on the treatment. And if it is a plaster with painted finishes on, exposed to the weathering, like in the case of this facade, that requires a different approach. And we had done an emergency treatment on it. The full-scale treatment hasn't been done, but I just wanted to describe briefly how that works out. Hope that helps.
Great, thank you, Alex. Jeremy, do you have any input on the consolidants question?
No, I think Alex covered it.
Great, thank you. The next question from Sonia is, are there best practices to follow when archaeological findings, such as a hearth, are discovered during adobe restoration? Is there anyone who would like to take that one? Yeah, go ahead, Jeremy.
Yeah, definitely. If you find any archaeological resources in a wall or adjacent to a wall during work, definitely should stop the work, document immediately what's been found, and contact the State Historic Preservation Office and begin to consult. If it's in a location where work needs to continue, some data recovery or mitigation might be needed if the work absolutely has to continue and that work could impact the archaeological resource or feature that's in or adjacent to the wall. Sampling of different kinds might be done if there's carbon, ash, charcoal, in order to get C14 or AMS dates, but definitely consultation with regional archaeologists, anybody else you know, and also SHPO if it is a historic property, and perhaps even if it's not. Again, if it can be avoided, it'd be better to leave it in place and avoid disturbing that archaeological resource. But if it can't, then some mitigations need to be put in place to salvage information, and documentation and data and collection of samples is kind of a minimum there, but avoidance would be best.
Great. Yeah, Jake.
Yeah, well, just one quick comment on this. I'm assuming that they may be digging up an earthen hearth. And so in excavating, if you expose any earthen fabric that is going to be exposed, one suggestion would be to very quickly get a protective cover or shelter over that until all these things that Jeremy is talking about can be done. Because should weather come, those very fragile architectural artifacts are going to deteriorate very quickly.
Yeah, great point, Jake. I mean, putting the same dirt you removed back on it until you can get back there, and possibly putting a marker over it that is not impervious to moisture, like a very weak weed cloth or something like that, would be helpful if you were to bury it and had to re-expose it to do that sampling that we were discussing. But I would say that if you're not going to get back to it right away, dirt would be better than putting a tarp over it. But you will need to mark where it is so that if you did want to go back and remove that dirt, you know where it is and you're not going to damage it with a shovel when you try and locate it.
Great. Yeah, Jake.
Do we have time to go back to Amanda's question about consolidants? I think it's rather relevant.
Sure, go ahead.
Okay. Amanda's question about treating original materials instead of encapsulating using consolidation. A lot of work has been attempted over the century in an attempt to come to a solution like that. It's a very spray-on chemicals, penetrating chemicals, whatnot. In earthen materials, in most cases, these kind of treatments do not work because they're film producing and create a shell of the existing adobe, which then deteriorates more rapidly over time. And so when we talk about compatibility with earthen materials, we really have to think very carefully about the soil matrix of the original and the material being attached as being fundamentally compatible, being earthen fundamentally, the clays, the sands, the ratios, so that you do not create that kind of shell over there. The encapsulation issues that Jeremy's talking about that's done very carefully with the shelter coat in between. And in some cases, over time, who knows? But that's a preservation technique that's been tried for a long time. It's in process. 50 years from now, maybe something else will come up.
Yeah, and this speaks to the sort of what Jeremy was mentioning earlier of sort of no one size fits all in this approach. And there was an earlier question, Jeremy, on your presentation about the veneer method. And the question was, doesn't that method change the character and integrity of the resource? You want to comment on that?
Well, for Pecos in particular, the resource itself was already in a ruined state. So we have to understand the site history, stabilization history, archaeological history of these sites. So archaeologists excavated the convento and the church. All of the original lime and earthen plasters had already eroded. And for a long period of time, those original wall remnants were left exposed. So when we talk about character, we do get into a bit of a conundrum. Which character are we referring to? Are we referring to what it would have been back then? Well, back then it would have been lime or gypsum plastered. The plaster probably would have been a mix of regular earthen mud and lime and gypsum, so it would have a dirty white appearance. We've decided we cannot maintain that kind of plaster because it's not a complete building system with a roof. We're dealing with ruins that are rough shaped, do not have parapets, are not covered. And that's where it gets into what is the condition of the resource you're coming up to when you think about treatments. So for us, veneering, we were presented with an already deteriorated adobe wall where all you see are the bricks, right? There's no plaster system in place that's original by the time the Park Service starts managing the site. And so therefore, in my mind, if we're doing veneering using bricks, that is in keeping with the character and materials of the site's original construction and the way that the Park Service found it. And because there's not enough left of it to restore it and put a roof on it and then plaster it, we are doing something that's in between. So to me, the brick veneer is in keeping with the character of the site and is actually more in keeping perhaps than plastering it on plastering the adobe wall remnants, having them deteriorate because we have uneven surfaces and us not being able to keep up with all that plastering and having it look very deteriorated all the time. Instead, we have the bricks that deteriorate in our shelter coat. So I hope that answers the question. If it doesn't, please follow up. Thank you.
Great. Thank you, Jeremy. There's another question, and I knew this was going to come up because Roplex was mentioned earlier on and talking about amendments. And so I'm wondering if any of you would like to take this on about the continued use of Roplex and the sort of incompatibility with original materials.
I'm happy to.
Maybe Jake could start it.
Sure.
I'll start that. I think it's important to recognize why this kind of material is being used. And the National Park Service has many adobe sites exposed, to the elements, particularly sites that are fragments. They're ruins or whatever you want to call them. They're fragments in the landscape. These are probably the most difficult type of fabric to preserve in an open environment. And the Park Service has struggled with this over 100 years, trying to find ways to preserve these for public interest, for interpretation, for history, for conservation of fabric, etc. And based on some work that was done in the 70s on test walls, these Roplex and Darrow weld, the two materials that came out, proved they had some efficacy and provided a little bit longer in the maintenance cycle. And so they were adopted. Now, I mean, your question is a really relevant one. And can we try very hard at Cornerstones to use unamended solutions. And so we're working hard to show and find ways that unamended solutions can be efficient in maintenance cycles. I'll turn it over to someone else.
Yeah, Jake made an excellent point. A lot of it has to do with durability and maintenance cycles, but also has to do with the ratios and the amount of Roplex that you add. At Pecos, we're adding a very small percentage in the solution, the water, the aqueous solution or water that's added to the dirt mix. And based on Hartzler's study and based on consultation with Bob Hartzler, who's still alive and did that study in the 70s that Jake mentioned, he felt like the ratios that we were using was probably not trapping moisture. But again, the key is that we are not applying Roplex mixes onto the original. There's always a separation of natural adobe plaster of a separation coat, because that separation coat is allowing any moisture that's in the original wall that's being encapsulated by the brick to leave within that space. And if there are salts, those salts are being dropped on that separation coat partially, so that any salts that might be in the water solution that's trying to get out of the original wall aren't staying in the wall totally. Now, there is some salts imparted, but we've done studies on the salts and found that they aren't damaging the kind that are damaging. So, each site, again, it's going to be particular to the situation, the condition of the original, what materials were used in the past. And you have to work with the soil materials you have available with these amendments. But the crucial part is that we're not adding a lot of it. And the little bit that we're adding is giving us extra durability to keep up with our maintenance cycles. So again, this is balancing multiple issues, and we've been doing it for a long time now, and there isn't a ton of evidence that it's causing damage to the original, as long as we have a separation coat and don't attach it to the original fabric.
Great, and Alex put in the Q&A. He'd like to kind of chime in on this conversation too, if we could unmute him. Alex Lim.
Hi. We have a ruined site that we applied Roplex amended soil render about 2-3 years ago. Before that, we used to just go out there, use unamended soil render like David Keller from Big Bend mentioned. There's pros and cons to both approaches. The approach that Jake takes at Joshua Tree, it's as he mentioned, it's very forgiving to the volunteers and people who are passionate about conservation of these ruins. And given the amount of walls that are exposed for protection, if you don't have easy access to someone who has a special training in how to develop a Roplex amended system that answers the compatibility issue, I would highly recommend not going with the Roplex route. And I say this not because it's necessarily a bad option, but if it's used really not well, if it's not done with proper experiments and testing, like I've seen in most places, you will end up doing more harm than good. When compatibility is at issue, it's not just about the color or texture, it's about how breathable it is, how well it adheres to the substrate underneath it. And so there are a lot of categories you have to systematically review to do it and observe how your chosen system weathers over time. And all of that takes time. So, I highly encourage anybody who wants to do Roplex, you have to understand the soil very well that you're going to use, and you can manipulate however you want for Roplex amendment. Roplex as a material is not permanent. It also fails. So you have to think about, well, what if the Roplex added soil render fails? Then what are you going to do? Let's say you hire somebody to come up with the best system. Well, what happens if you run out of the soil that you started using for that initial testing? You have to go through this all over again. So in a way, Roplex might sound like this is a neat option because it'll give maybe extra durability for all the sites we have, the ruins we have. After 2-3 years, you'll realize, oh no, we have to redo it all over again. and it seems like it's going to add up more time and money. On the other hand, the unamended soil render, however short, lifespan it might have, like Jack mentioned, is very forgiving, very forgiving. And as he mentioned, some of these sites in New Mexico or elsewhere have seen that particular use last a long time. So again, it really depends on what type of resource you have, what type of heritage sites you have, whether it's a ruin, whether it's a complete building that gives some kind of protection to the walls, and whether you have resources, not just the short term, but in the long term, whether you have the technicality to do it. And really, lastly, you have to think about what do you intend to get out of that particular use? If the goal is the community outreach through these heritage sites, then to me, not using Roplex, going with the forgiving material may be a better way to increase the awareness of the fragility of earthen sites.
Great point, Alex. Yeah, thank you. Jeremy, did you want to add on to this?
Yeah, I think it's important in this discussion to also put context, and I appreciate Alex's comments. Thank you, Alex. That, Alex is talking particularly about Roplex use in plaster. In the Pecos example, we were talking about Roplex use in bricks. So again, different applications, different things to consider. Also, the Park Service does not use Roplex without testing. And so I think Alex's point about testing, working with the materials, understanding what you're getting into before you do it is very, very true. And honestly, there's so many resources to manage that a lot of the decision to use amendments like Roplex comes down to the reality that we would not be able to keep up with maintenance if we were using unamended all the time in the Park Service. But there are cases where use of unamended plasters and brick are warranted. And we have test walls at Pecos and where we're comparing unamended veneers to amended veneers. And the results are telling us actually that a hybrid approach for our veneers might be best, where the cap is unamended and the sides of the walls or the bricks themselves are amended with Roplex. We're actually finding that the caps being unamended, the cracks self-correct more often, and moisture isn't so concentrated in vertical rigid cracks compared to a cap with Roplex. So testing is ongoing. We don't just pick a method like Roplex and not reconsider how we're doing it, because we always need to be sure we're not doing the resource damage. So thank you.
Yeah, no, good point. And it goes back to something I've always observed with the national parks, is that they are indeed laboratories, and that they should be seen as laboratories. And, not everyone in the previous generations were perfect, nor is this generation perfect, but it's a constant experimentation. And thank you, Lauren, for your comment there too, about mud plasters. And of course, if we had our Mexican colleagues here in this roundtable, they would not use amendments at all. And so it's a completely different philosophy about how amendments are approached. And we're discovering a lot of the factors that are involved here. And going back to the mantra of this session is that no one size fits all here.
Brooks, can I
yes,
just jump
Francisco.
In there?
Yes,
I think that the only, if you want to consider amendment, would be lime, which is very compatible with earth, and it's a permeable, material that, like I mentioned, very, very compatible with earth. But it has to be done in a very, very small percentage when it comes to the earth. I think Luis Fernando is on, viewing this. So the other thing is that, according to Luis Fernando, it's also, you have to consider the pH in the soil, and that will tell you how much lime or the percentage to that pH in the soil, and balance that out, to have better results when it comes to, the amended with lime soils, but it's a fairly natural material. So
great.
Just wanted to throw that out.
Good. Thank you, Francisco. And James, there's a question for you from Alex Lim about how long did it take you to straighten the wall that trenching shoring system was used to counter the rotation? 1 day, 2 days, 4 hours?
It actually happened extremely quickly. It took us less than 4 hours. So when we went in and everything was set up, we first moved it about an inch. And it was just hard to believe, that it was moving. And the jacks were responding wonderfully. And then it was a jacking process where it was limited by the stroke of the jack itself. So we had a 6-inch stroke on the upper jacks. So we would go in and jack out to that distance and then block it and then come back in and rehang the jacks. But it was surprising that it went so quickly. But everything was in place. I mean, the process was well thought out. I was thinking about all the conditions. I mentioned that back panel that we pushed up against, and so that I couldn't push it over, right? I mean, and then it told me when the wall was then plumb. You needed all those things in place. And we had people watching all over. I mean, everything. And, I would station people to tell me, if you see this here, call me, and you can say stop right there. And it was very choreographed in terms of the process.
Great. Thank you. Yeah, Jeremy.
I was just thinking a little bit about the character question too. And I think one thing we've been kind of talking about amongst us and relates to our experience and what kind of sites we've worked on is that, in the Park Service, we're often preserving ruins. We're preserving structures that are in a ruined state. And what that means and how you do it and how it relates to character, significance, setting, are all things that come into play versus a complete building system. So we have to make often different decisions when we are trying to preserve a site as a ruin. We're not wanting to rebuild it all. We're not wanting to make flush surfaces to everything. We're trying to sort of keep things as they are as much as possible, which is really a losing battle if you think about it. And there are a lot of arguments and discussions we often would get into with our Mexican counterparts about restoration and about this whole idea of preserving a site as a ruin, because it is almost impossible.
Yeah, and Jeremy, right on the money. And so the straightening of that wall was balanced against it failing and taking out a third of a bunch of the original structure, right? In terms of the Martinez adobe, that structure in its current state, if there was an earthquake happening on the Concord Fault, the Hayward Fault, that building would likely collapse. And so once I realized that risk, informed the superintendent, and they took everyone out. So the intervention component goes hand in hand with the risk, maintenance of the structure. What happens if it fails? I mean, there's all these questions that have to get answered. And it's a large conversation. Many people are able to talk about it. I can facilitate actions in terms of, engineering and planning and trying to fix things, but it's a big decision.
Well, and this is a good plug for our final session of the 5, which is talking about management priorities. And really trying to understand all of the factors and weighing the value of all of those factors and making decisions like that, because intervention by itself is partially destructive, and you just have to make those kinds of decisions based on weighing all those values. Evan brings up a really interesting point about the age of climate change and how, indeed the past doesn't necessarily work today or into the future. Anyone want to sort of comment about any changing views based on climate change?
Yeah, I would like to start out. I've been called into quite a few sites in different structures now with mainly heavy erosion. either direct erosion of surfaces or undercutting of foundations. But it's really coming in hard. Another problem there at Fort Union with climate change are the winds. There are these really strong winds, and the wind erosion is huge at that site. So it isn't just water, that comes in to the degradation of the structures.
Great. Anyone else want to
Sure.
report, Jeremy?
I think the one thing I worry about the climate change discussions we've had in relation to earthen architecture is it almost wants to push you towards using more hardening substances, because we're talking about some of these sites that are in a ruined state, and we're getting more intense rainfall events, these high intensity, long duration, and the knee-jerk reaction is, oh, we need to protect things more. Well, we already have learned that adding substances and amendments that are too hard, like cement and doing cement caps and these kinds of things, are more damaging to the structure. But this is one thing that's been worrying me about the climate discussion, because I have heard some increasing discussion about we need to have more durability, we need to have more hardening substances. And we've already gone through 100 years of testing to show that that's not the way to go. Yes, we're using amendments at Pecos, but we're using it in a small amount, so the material is still relatively soft. We're not over hardening. So I think we need to be careful in the climate change knee-jerk reaction, but it's a difficult problem.
Yeah,
So,
James.
Yeah, in an analogous way, so like with the Martinez adobe, by using that base isolation, you insert a fuse in that system. And one way to think about those materials, Jeremy, is it's a material that's designed for limited use, in this case, limited erosion process. So you give it a lifetime, and it fuses, it erodes, it does its job, and will erode away. But it should be planned in that kind of context.
Yeah.
And a lot of things we're doing are sacrificial, right? And so
Right.
we're not meaning for them to exist forever. They are part of a maintenance program and should be. So when we talk about Ropex plaster is going to fail or Ropex bricks are going to fail, anything we put up is going to fail. That's the whole point. Because if we put up cement thinking it's going to last forever, we've already found it damages the original more. So we have to understand those maintenance cycles, understand and be prepared with budgets and money, to deal with that cycle of maintenance.
Well, and Anne brings up a question here about sort of the economic kind of analysis of the use of amendments really saving money over versus the higher labor costs. Has there ever been that kind of an analysis done?
I don't know if it's been really formal, although if you've worked in a park that have tried both, you can kind of see it, but each situation is different. I can tell you that if we use unamended bricks at Pecos, it would probably it would decrease our cycle. I mean, we would have to replace them probably every 2 to 3 years versus every 5 to 7. And it doesn't take more labor to make a Roplex brick than it does a normal brick, or to lay it and build the veneer. So I don't think the labor is a big difference. Now with some other applications, it might be, and material costs are part of it. Roplex is a little expensive, so maybe that factors in. But I'm not sure there's been a formal analysis.
Great, thank you. And the last question is really for you, Jeremy, and then we're going to close this session. Are you monitoring climate at your sites?
We are. We have 2 weather stations on site. We have one that's a real-time weather station that gets duration and precip every half hour, and then we have a NOAA weather station that's been there for 100 years. And I can't say that we are seeing drastic differences. I think the biggest difference that's been seen across the nation is when we do get big rainfall events, they're more intense. More rainfall falls within a given period of time.
Yeah, and then Jeremy, didn't Professor Matero, didn't he install some moisture gauges? So he's measuring he's measuring licking now, capillarity coming up through the walls in relationship to rainfall. So
we're just starting that, and we've also been using time-lapse photography to understand where moisture stays throughout the year in different aspects of the walls, north versus east versus west, how snowfall accumulation affects our erosion patterns. But these are all things we need to do when we manage these sites to develop better treatment options.
And I use infrared all the time, and that infrared tells me I have solved so many problems with infrared. I can't suggest a more affordable tool to give you immediate information than a little FLIR, you know, C2, C3, and boy, that just tells you where the problems are.
All right, we're at time, and I'd like to, in closing, like to thank all of our panelists today, as well as the audience participants who have provided questions for this discussion. I do want to remind folks that the video recording of this and all the SICRAT sessions will be available on the Missions Initiative website, and then later on at the Terra 2022 website. And the one on the Missions Initiative website will be ready in the next few weeks, and we'll be sending out a notice to all the participants when that goes up. And finally, I'd like to please ask you to join us in a week from now for our next SICRAT session. That's preserving and maintaining earthen mortar in adobe and stone masonry structures. So if you haven't already registered for the session, please go ahead to the SICRAT website. And we look forward to seeing you next week and next year in New Mexico. And so long for now. Thank you.